So 2.1, guys, is called rates of change and limits. So let's start with the definition of limits, okay? So the first definition of our calculus unit, we will start with the notation of limit. Okay. So this notation, students, is coming from both sides. From both sides. And it says, the limit as x approaches c of f of x equal to something called L. And I'm gonna write how we read it. So this is red. The limit over f of x equals L as x approaches c. Okay, that's how we read that. So for that definition, for c, anybody remember what the symbol means? The E symbol? What is that? Flip? Yeah, it belongs in the set of all real, right? So that for C belongs in all real, and if it's Z, then it's just integers. But this case is all real. It means I can pick any number for C that I want. And L is the height the function is approaching as x is getting closer to c. If f of x is continuous, and a continuous function, guys, meaning that we should have no holes, no jumps, no asymptotes. Okay, then the limit, I'm out of space, I'm going to write over here. Then the limit as x approaches c of f of x is identical to f of c if, like I said, okay, so if f of x is continuous, then this is true. If I'm going too fast, please let me know so I can slow down. Right, Casey, can you help me read example 1, please? Perfect. It says use the graph to estimate the limit and value. So part A, student says, find the limit of f of h, which is this function right here, as h approaches 0. So this part A is your calculus kind of question. Now part B says find f of 0. This is more of an algebra kind of question, okay? Now let's look at it really quickly. Here's the function. Let's do B first, because B is easy. Just like the warm-up. What is the answer for B? What's f of 0? -4. Yeah, we're going to pretend that it's right there, -4. So based on algebra, it's -4. Would you guys agree? Now calculus says, hey, find the limit. And based on the definition of limit, students, it's what's happening to the y. What is the height? As y, okay, what is the height? We'll just find the y value. As x is getting closer and closer to what? 0. So when x is getting closer and closer to 0, and it says from both sides, so I mean left and right has to be the same. What's happening to the height? Up or down? Down. So I'm getting closer and closer, and the y is getting closer and closer to what? -4. So in this case, the algebra and the calculus are the same, and they are the same answer because look at the graph for me. Is the graph continuous? Yeah, continuous means there's no hole, there's no break of any kind. So because it's continuous, can you see that the algebra view and the calculus view should always have the same answer? Okay, all right. Let's review some polynomial and rational functions. Angie, are we going too fast? Okay, good. I just want to make sure. Okay, here we go. Polynomial function, students. This is continuous and smooth, okay? And smooth. Now, rational functions, you guys remember, what do they have in the rational functions? I'm going to give you one. Y equals 1 over x. That's a rational function. What do you guys remember about these? Like y equals 1 over x squared. What do those have? Asymptotes. Yep. These will have asymptotes. And asymptotes, by the way, why do we graph asymptotes? Why do we, when we graph them out? Why do we graph asymptotes? What do asymptotes represent? Shannon?
An area where you can't have an answer.
Yeah, asymptotes graphically represent what x cannot be, right? And what y cannot be. Do you guys agree? And that's why we use those dashed line. Okay. So number 1 said general formula for the polynomials. So it's going to have f of x equals a sub n times x to the nth power. So a sub n, those are your leading coefficient, and then n is your power. So if it's x to the 10th, then the next term is going to be a sub n minus 1, whatever the leading coefficient is. And then we're going to write it from descending order, meaning the highest power to the lowest. So we started from n, at n being 10 power, then the next one would be 9, plus dot, dot, dot. And then we're going to go to a sub 1 times x, which is power of 1. And the last term, if you have a constant at all, then that means x go to the 0 power. Anything to 0 power is always what, guys? 1. So that's why the last term only has a constant there. Okay. So since this is a polynomial, the limit as x approaches a c value of whatever the c value is of the polynomial, again, polynomial, continuous, so that means the answer of this limit should be exactly the same as an algebra value. Okay. Rational function, not so much. So a rational function is r of x equals, we're going to have something divided by something. So p of x over q of x, where p of x and q of x are polynomials. And the denominator, which is q of x, cannot be 0 ever, right? And r of x is usually not connected. When do you think it's not connected? When do you think the asymptotes happen? Who remembers that? We know we have asymptote. When do we? It's not connected. I mean, we have asymptotes. Where do we have the asymptotes? When is it that x cannot be defined? The top or the bottom? When the, can we divide by 0 ever? No, so that's why we take the bottom and we set it equal to 0 to find the location of the asymptote. Do you guys remember this? Yeah, then that's what's happening. Okay. Now, as you can see, because this is not continuous, we don't have an algebra connection with the limits. Okay, does not mean we don't have a limit, which is not the same as your algebra value, or may not be the same as your algebra value. All right, here we go. Oh, I want to make sure I'm not going too fast. All right, Nadia, help us read number 2, please. Determine the following limits. Here we go. Part A, find the limits as x approaches a negative half of 3x squared times the quantity 2x minus 1. First, is this a polynomial or a non-polynomial? Polynomial. So when we FOIL that out, wouldn't you guys agree that we have a power of 3 and then less and less? So because it is a polynomial, we use substitution straight up, like an algebra value, okay? So use substitution, since it's a polynomial. So to find the limit, all we have to do is plug in what for what? Every time we see an x, what do we plug in? A negative half. Let's do it. So negative half squared, 2 times negative half, minus 1. All right. In your team, actually work it out independently and then compare your answer once you have it. Please verify with each other. It's okay to talk, guys. All right, Jasmine, what's your final answer? Negative 3 divided by 2. Yes, no, maybe? Yeah? Yeah, okay. Right, B. Find the limit as y is approaching negative 2 of our function y squared plus 5y plus 6 all over y plus 2. All right, guys, let's substitute. Ready? When we plug in for, every time we see a y, we're going to plug in what? All right, so negative 2 squared plus 5 times negative 2 plus 6 all over negative 2 plus 2. What's negative 2 squared on the top? 4 minus 10 plus 6 all over 0. What's on the top? 0 over? Oh my. Did it work? Substitution does not what? Now what? What do we do now when substitution does not work? Oh, I love you, Lily. Okay. Factor. All right, we are going to drop out our F-bomb. How good are we at factoring? We better get good, right? So factor out the numerator and denominator to see if things can be simplified, reduced. All right, so factor out the top. Let's see, Aiden. Do you know what the factors are for the numerator, Aiden?
Y plus 3 times y plus 2.
Y plus 3 times y plus 2. Then reduce. When we reduce, what can we cancel? Y plus 2. So we only have y plus 3 left, right, guys? Now can we substitute? Yes. Okay, so now we're going to substitute in negative 2 plus 3. What is our limit when y approaches negative 2? 1. Okay, so guys, as y is approaching negative 2, the height of the graph is approaching what? 1. That does not mean we have an algebra value. Does that make sense so far? We may or may not, but we just know that right now it's approaching the height of 1, okay? All right. Lily, are we going too fast? Yeah. No? Okay. I want to make sure. I never know. Okay. Right-hand limit, left-hand limit, and two-sided limit. Okay, so our right-hand limit is this. The limit as x approaches c, and then we use the plus symbol to indicate it is the right-hand limit of a function. Let's call it f of x. Okay. So we read this. Okay. This is red. The limit of f of x as x approaches c from the right. Okay. Left-hand limit, take a wild guess. What are we going to use to indicate left-hand limit? The minus, yep. And it's read the same way. Okay, so this is the minus. So instead of from the right, we say from the left of our function f of x. Now, two-sided limit is when we don't use left or right at all. So the limit as x approaches c of f of x. Guys, the two-sided limit exists if and only if the right-hand limit of the function is exactly the same as the left-hand limit of the function. Okay, part C, number 3, I want you guys to sketch that out for me. If you don't know how to sketch it, can you please ask your neighbors? We'll give you guys a minute there to sketch that out. Just sketch it out. Friends, help each other out. If you're stuck, just tell your friends you're stuck. Get some help. If you guys don't know how to sketch it, is it okay to make a table? Yeah, make a table. Take some x values. Take some y values. Okay, we'll do the first piece. A piecewise just means you have multiple pieces, okay? So on the first piece, bless you. On the first piece, Luke, what is the first x value that we have to pick if we're making a chart? We're going to start with 2. Guys, why do we start at 2? Yeah, because it says less than 2, but we have to pick 2, knowing that dot has to be what kind of circle? Open, all right? So Luke, plug it in. What do we get? When x is 2, y is 1. And then we guys know this is an open circle, okay? Then, Shannon, give me one more value for the first piece. -3. All right. Shannon, plug it in. What do we get?
0.
For the first piece?
Oh, never mind.
3. Well, we have to pick less than 2. So let's keep it -3. But when x is -3, what's y? Good. So we have 2 dots. We're good. 2. Open circle at 1. And then negative 3, 2, 4, 6. So it goes here. Arrows on the ends. Okay. So that's my first piece, second piece. And no, you don't have to use the table. If you know how to graph it, totally okay. Second piece, Tommy, what is the first x value that we have to pick? 2. Plug it in. What do you get for y?
0.
2 divided by 2, bud, is what?
2.
Okay. Open circle or close?
Open.
All right. Then I need another value. Lindsay, what's your next x value for the second piece?
5.
How about pick something that's divisible by 2? Okay. 6, 4, is that okay? If you have a fraction that's denominator 2, we want to pick something that's friendly. I mean, don't get me wrong. Pick 5. You can pick 5 all day long. Okay. 6 divided by 2, Lindsay, is? 1. Perfect. So 2 is 2, 2, 4, 6 of 4. Is this what you guys have? Maybe? Okay. All right. Part B. Emily, help us read part B. Perfect. Let's write those down. We want to find the limit as x approaches 2 from the right side. And then the second half of the question is finding the limit as x approaches 2 from the left side. Okay, we just defined those. So just like what it said, guys, if you guys are looking for the limit as x approaches 2 from the right, which is the correct piece? The orange, well, looks like red from here. The orange piece or the green piece? If we're looking for the limit as x approaching 2 from the right side, which piece? The orange piece, right? Just like what it says. You look at the graph, you imagine yourself the right side. So you put yourself on the right side, which is now the orange piece. Can you see that's an open circle? That means algebraically it does not exist. But that doesn't mean we don't have a calculus value. As x is approaching 2 from the right side, what is the y value getting closer and closer to? 2. It doesn't exist, but it should be very, very close to what? 2. So that right side is 2. Okay, so this is 2. So again, if it's the right side, you imagine yourself standing on the right side of the graph. That leads us to the other side. I'm sorry, this one's left, and I do a plus sign. Let's look at 2 from the left. As x approaches 2 from the left, so is it the green piece or the orange piece? The green. So you put yourself on the green piece and go towards 2. What is the y value getting closer and closer to? 1. Right? They're not the same, but that's okay. They don't have to be the same. Does that make sense, guys? Okay. Part C. Kiara, help us read part C. Okay. Does the limit exist as x approaches 2? So Kiara, what is your answer? For the two-sided limit, there's not a plus or minus, right, guys?
No.
No, because why?
Because it does not touch 0.
They're not what? Yeah, because, oh, I wrote because twice. Because the left hand limit and right hand limit what? They're not equal, okay? Left hand limits does not equal the right hand limit. Okay. Okay, here we go. Let's test out some more basic limits. Which of the following statements are true about the function y equals f of x? Which, look at that. I don't even make you guys sketch out the piecewise. I'm giving you guys a piecewise, okay? Which is false. All right. How about I'm going to give you 2 minutes to see if you can do A to I. Do it in your team. Talk it out. Teach each other. Help each other out.
So as how is it negative one? Oh, from the right side. So it goes to negative one from the right side. But it improves what's the right hand. I don't know what DNA is.
Present, can you print from home or no? Yeah, okay. I think if you need help with printing, so they know, okay?
It's this is the right side. Oh, this gets to yeah, it's the same. Oh, from the right. It's false. It would be one. As we're approaching 1 plus 1, wait, no, the dot. As we're approaching 1 from the right side.
Wait, so when there's like no cost in that, that's like a both sides.
I would think it's I'm going to it's just that every seed I don't know what
Actually, maybe I'm wrong. It's okay to be wrong. Just argue you'll be wrong. And we'll find out. Alright, guys. A, the limit of f of x as x approaches negative 1 from the right is 1. Angie, do you agree with the statement? True or false? For A. True. Question mark? Did you confirm with your team? Yeah? Do you guys agree with Angie? Okay, so let's talk about this. The right side means you're standing on the right. Okay, well, here's negative 1. There's nothing on the left. Would you guys agree? Hence, there should not be anything existing on the left side. So if we are looking for the right hand, we need to stand right here. You shouldn't be standing over here. So we're going to pretend that you can't jump. There's no boat for you to get over here. There's no airplane, which is going to crawl, right? So we're going to crawl towards this. So you can see it is going to hit the y value of 1. So let's shoot. All right. B, Kara, true or false?
false.
False. Okay. Can you tell me why? Justify the false?
When x is 2,
Mm-hmm.
is a point where they reach the same point on either side, which is 2. And so the C also has that. I decided that C is true and B is false.
Okay. So the question for this one says, oh, by the way, DNE means what? Does not exist. For the two-sided limit to exist, the right hand and the left hand must be exactly the same. Let's do the right hand. Actually, this question probably do the right hand. Let's do one with right hand. Nope. Okay, so let's do the right hand. So here's when x equals to 2. Right hand means we're standing on the right side. Would you guys agree? We're getting closer and closer to x equals to 2. What is the y value? What is it getting closer to?
Oh.
Aiden? What is y value getting closer to if we're doing the right-hand limit?
1.
It is 1. Okay? Remember, the limit does not have to be equal to the actual algebra value. Does that make sense so far? It's just what the y is getting closer to. So this one, the right is 1. How about the left-hand limit? As we're getting closer and closer to x equals to 2, what is the y getting closer and closer to? Also 1. They're the same. So does it exist? Yes or no? Yeah, so this is false, okay? Limit as x approaches 2 from the left is the same as f approaches 2 from the what? Right, and they're both equal to what? 1. Okay. Okay. All right, Preston, C. The limit as x approaches 2 of f of x is 2. True or false, Preston?
True.
True. Do you guys agree with Preston? No. Why not? Because the y is 1 and plus. Didn't we just write this right here? Right? What is that right there? Okay, so this is false. So guys, then let's talk about this dot right here. What is that dot? It's a singular dot. It's an algebra value only. F of 2 is what? What's f of 2? 2, and that's it. That's all it's good for. Okay. All right, D for dog. Beatrix, the limit as x approaches 1 from the left is 2. True or false? True. You guys agree with me? Yep. If you're doing to the left, here's x equal to 1. You must stand on this branch. Yes or no? And you stand on that branch, the y is approaching 2. E, Julio, true or false?
True.
True. We're looking for the limit as x approaches 1. Is that plus or minus? Plus, okay. Plus. So, again, it's true because the y value, if we're doing right-hand limit, we should be standing on this piece, right, guys? And here's the y value. Okay. Philip, F, true or false? True, because the reason is really part D and part E, right, Philip? Yeah. Oops. G, R. Okay, so the reason is really because the left and right, they are not the same. G, Andrew, true or false?
This be false.
Andrew said to false. Do you guys agree? Yeah? It's false? No? I see yes and no. Okay, let's do one piece at a time. What is the limit, students, as x approaches 0 from the plus sign? What is that answer? It's 0. From the right side, we stand in this, right? What is the y value as we are sliding down? What's the lowest value is going to go? 0. Now, left side, I'm standing here, right, y'all? If we're sliding down, what's the lowest value that's going to go? So this is true. All right, H. The limit at x approaches c of the function f of x does exist at every c when c is in between -1 and 1. So let's talk about that question before we type. Can you guys see that it doesn't have a bracket? Doesn't have a bracket means, do I care about the endpoints at all? No, it can be open. Would you guys agree with that statement? Here's -1. Here's +1. C, x is approaching C. That means C can be anywhere in between here and here and here and here and here and here and here. Would you guys agree with that statement? Is that piece continuous? From -1 to 1, is that piece continuous? Based on our definition of continuous, does the limit exist? Yes. Okay. So if it's continuous, the limit will always exist. So that is true. All right. Then let's talk about I. True or false, the limit as x approaches c of x exists at every point c when c is in between 1 and 3. Okay. Very similar but not identical. Here's 1, here's 3. Again, it's parentheses, so it means the endpoints don't matter. Does that make sense so far? Is this piece continuous? It's not, but that does not mean it doesn't have limits. Okay? So is the limit every single x value in between here? Is the right and the left, are they identical? That's really the question. Is the limit identical? Okay. Now, would you guys agree the questionable c value is at 2? Questionable c value is at 2, true or false? But didn't we talk about at 2, the limit exists or did not exist? It did exist, right? Well, if the questionable value is at 2 and it exists, then everything else is really continuous. Would you guys agree with that statement? If that's the case, then does this I exist? Yeah. Every single value in between 1 and 3 has the limit. So guys, this is true. Okay, let me make up one. True or false? The limit as c x approaches c of f of x for every c in between, let's say, 0 and 2. True or false? False. Why false? What would be the questionable x value that will make this false? Yeah, x at 1 makes this statement false because the left hand is what? 2. The right hand is? They don't match, therefore it doesn't exist when x equals to what? 1. So that makes the whole statement false. Okay? Does that make sense how that goes? Uh-huh.
So for H, since you said that endpoints don't matter, is that why it's true? Because like 1 and 2 is not inclusive.
Correct. The endpoint can be closed, the endpoint can be open because we don't count the endpoints. All right, let's go to next page, properties of limits. So we have, as you can see here, a few properties. So we'll start with the limit as x approaches c of, let's give us a function f of x, and then let's say it equals L. And we're going to have another one, the limit as x approaches c of g of x equal to m. So property number 1 says you could actually add them, so the sum rule. So if we said find the limit as x approaches c of 2 functions when they add together. Sometimes that's a bit more difficult to do. So normally, if it's easier to break it up, then break it up, and that should give us the same answer. Okay, so when we have a summation of 2 functions, we can break it up and get the limit independently and then add them together at the end. That will give us the same answer. That it's going to be similar with when we subtract the 2 functions. So the limit as x approaches c of f of x minus g of x. Again, if that's too difficult for you guys to find them together, then find them independently and then subtract. And same goes for product. The limit as x approaches c, if we say, okay, f of x times g of x, okay, we can break it up. We can go, okay, limit x approaches c of f of x, find that first. Find the limit as x approaches c of g of x. Once we have the answer, we multiply the product of each. Same thing with quotient. So the limit as x approaches c, that looks like an e, of f of x divided by g of x, we can go and break them apart. F of x divided by the limit x approaches c of g of x, which is going to be L divided by M. All right, feel like I'm going to invade this space. I'm going to give you guys a minute to finish that before we go on to, we have constant multiple and quotient. I'm saying not quotient, power. So this is the separation here, so I don't invade the next space. All right, constant multiple so if we have the limit as x approaches c of some constant, let's call it k, times the function f of x, it is the same thing as saying, okay, take out the k, do the limit as x approaches c of f of x. Once you get the answer, then you multiply to k. And last one is the power rule. Okay. So if you have the limit as x approaches c of f of x and then raised to the power, it's the same as saying the limit as x approaches c, do just f of x, just get that answer. Whatever that answer is, now raised to the power outside. So that's the same thing as L to the P. All right, I'll let you guys write, and then we're going to do this example 5 to practice the properties. Who did not bring his or her ID today? Okay. It's okay. He'll still check out the book for you. You just have to go last. He'll ask for your ID. But we all have ID, right? All right. Let's do. Andrew, help us read the instruction for numero cinco, por favor.
Assume that the limit of f of x is equal to 7 and the limit of g of x is equal to -3. Determine the limit.
As x approaches what?
As x approaches b.
Perfect. Okay. All right. First, as you can see here, we have two functions adding together. They're both approaching the same value of b based on our properties that we just got done writing. This is the same thing as breaking this up. Okay. Find independently the limit of each and then just add them together. All right. Annabelle, what is the limit of f of x as x approaches b based on our instruction? Great. And Paige, what is the limit as x approaches b for g of x?
-3.
Great. Let's add them together. So Drew, 7 take away 3 is?
4.
4. Look at that. Easy peasy. All right, you guys practice B, C, and D in your team. I'll put 2 minutes on the clock. Once you guys have your answer, can you please confirm with each other? Talk to each other. Share the answers.
Okay, so we got 4 for A, for B I got -21, for C I got -12, and for D I got -7.
If I could incorporate the last chapter too.
Oh yeah. I don't think it
All right, Drew, what's your answer to B, bud?
-21.
-21. Parker, do you agree with Drew?
Yes.
All right, Parker, what's your answer to C?
-12.
-12. Melanie, do you agree with Parker?
Yes.
Yes. Amel, what's your final answer to D?
-7.
-7/3. You guys all confirm? All right, let's move on to sandwich, aka squeeze theorem. I do believe our book is using the term sandwich theorem. If I steal worksheets from other books, because our book is so old, it doesn't have anything, some of them call squeeze theorem. All right, so let's talk about sandwich, or the word squeeze. How do you make a sandwich? 2 pieces of bread and then? That's right. So, all right, so that's why they call it a sandwich, aka squeeze theorem. So can you digest this? Let's rock and roll. All right. So it says here, we only need to use this. Only needed if we are finding the limit of a function that oscillates. Okay, so an oscillating function, students, it's when it moves too much, like it's like this. And then we can't really pinpoint the height, okay? It's just too hard for us to identify where is the y value approaching. So that's when we use this. So based on that, we would say if g of x is less than or equal to f of x, which is less than or equal to h of x. Okay, as you can see, f of x is being squeezed in between what two functions? G and h, you're right, okay. And they have to all be on the same interval from a to b, inclusive. So, and if the limit as x approaches c of g of x is identical to the limit as x approaches c of h of x. And let's say they're going to come out to be a nice answer L, whatever L may be. So if the g of x limit equals the h of x limit, what can we conclude about the limit of f of x as x approaches c? Remember, f of x is in the middle. Then the limit as x approaches c of f of x is also L. So think about this. If I said, okay, everyone line up. I don't know how tall Brandon is. I don't know how tall Luke is. If Luke and Brandon are lining up, and let's just say, I'm going to throw out a number. They're 5 feet 10. And there's someone in between, and you guys are lining up from tallest to shortest. If there's someone in between, that person should be 5 feet 10, right? Because those kids are lining up, so that's what's happening. Okay, let's go and use it on the next page. How tall are you boys?
5'11".
Oh, so close.
He just said he was 5'10".
No, 5'10" and 3/4.
Okay, use the sandwich theorem to find the limit of at x approaches 0 of x squared times cosine of 1 divided by x squared. Obviously, guys, if we can substitute, that's the easiest go. Okay, so let's substitute first to see what happens. All right, let's substitute. So when we find this limit, we're going to plug what in for what? 0. So 0 squared times cosine 1 over what? 0 squared. Ooh. No, can we have a 1 over 0 squared? No, sad day. Okay. So we can't have 0 in the denominator. Therefore, this will give us our substitution. And I'm going to write both the steps at the same time. Steps for using the sandwich theorem in general. So I'm going to write the steps and then we'll go up and work that out together. Step 1. Take the trig apart. Find its minimum, maximum, aka the range. And then we'll apply that immediately up here. What trig function do you see in this problem? Cosine. What is the range for cosine, y'all? It goes from -1 to 1, and that's what it's saying. Take cosine apart, so cosine of x. The range is between -1 and 1. Do we remember transformations? Yeah, a little bit? Okay. Because we do need to apply these. Okay, so step number 2, we'll write the step and then we'll test your transformation. Next step, we are going to either multiply or divide or add or subtract, okay, whichever operation. The remaining parts to all 3 inequalities. Okay, I'll let you guys write before I go up. We might have to stop after this step to go get our book. Okay, so here we go. Let's look at this really quickly. So as you can see here, we have this that we need to multiply. Can you guys see that? And this right here as well. True or false? Okay. But remember, we need to see what's changing the range and what's not. So here's your basic parent function. If we go in and we do this, is this changing the range at all? No, because that's a horizontal what? translation, right? So if it's a horizontal translation, it's not changing the range at all. Right, I'm almost. But we're doing cosine. Okay, so it's not changing. So what if we go in and do this? Is that changing the range at all? No. Anything we do with the x, it would not change your what? Y, okay? So that's step number 2 we're going to do. So step 2, obviously we're going to go in and do cosine of 1 over x squared. Can you see that I'm not changing the range? So the negative 1 and 1 is going to be the same. But the next half that I'm going to do is, okay, is it going to change the range if we multiply cosine by 2? Yeah, the front number is what's changing the range because it's changing your amplitude. So because we are going to multiply the middle, guys, by x squared, so that means it says here all 3 inequality will get the same treatment if it changes your range. Okay, so this one right here, all right, and then I'm going to stop right here because we do need to pack up. I do want you guys to take all of your stuff.